Hey everybody, Anna and I are working through some balancing chemical equations. So we are first looking at balancing equation between phosphoric acid and potassium hydroxide. So Anna has written phosphoric acid, which you should memorize, is H3PO4, and she also knows that potassium hydroxide is KOH. Then she's going to write the two products. In this case, an acid plus a base results in two products, water and a salt. And Anna, what's the salt this time?
The K3PO4.
Right, and that's called?
Potassium phosphate.
Good, potassium phosphate. Okay, then she balanced it. She said, oh, I have 3 Ks on one side, so she put a 3 as a coefficient on the other side. To balance the potassiums, then she has 1 PO4 on each side. That was already balanced. So after you consider the two components of the salt, the K3PO4, then you consider the H's and O's to make the water. So then she looked and said, okay, now I have 3 hydrogens from the phosphoric acid, 3 OH groups from the KOH. So together they'll make 3 waters. So she balanced that, and that is all good. And the sun is making it hard for me to film, so I hope you are seeing that. All right, next one is nitric acid and barium hydroxide. So hopefully you've memorized nitric acid, HNO3, good. And barium hydroxide. Remember, barium has a 2+ ion, so barium hydroxide would be Ba, 2OH, 2 hydroxide groups there. Again, this is a situation where you would make a water plus a salt, and your salt is going to be what?
The barium nitrate.
Barium nitrate. And she wrote it correctly because barium has the 2+ charge, nitrate has a 1- charge, so Ba and then NO3 2. And it's balanced. She considered the barium, 1 on each side, that's good. Then the nitrate, there were 2 on the product side, so she put a coefficient of 2 on the reactant side for the acid. And then once the salt was balanced, she thought about the H's and OH's to make the water. There were 2 H's, 2 OH's, so she made 2 waters, and that's perfect. Last one, now this is one of those covalent situations. This is hydrobromic acid plus water. So remember, water, amphoteric or amphoprotic. So it can act as an acid in the presence of a strong base, and it can act as a base in the presence of a strong acid. Clearly, hydrobromic acid is an acid, so water will act as a
base.
Water is going to be a base. And remember that when you do these, the definition of acid was a proton donator. So the base is going to be a proton acceptor. So if water is being a base, it's going to take a proton. It has gained a proton. So it was H2O. Now it has one more proton, H3O plus, a hydronium ion. And of course the acid was a proton donor, so from HBr it gave away its H. Now it's just a Br minus ion. Remember, when you have a covalent situation, a covalent acid or a covalent base, you're going to make 2 ions as a product instead of salt and water like you're used to. So in this case, hydrobromic acid plus water gives us a bromide ion and a hydronium ion. Is it balanced? Yes, good. Okay, so we've balanced 3 acid-base reaction equations. Great. More later.